We're doing exercise 8B of differentiation at Excel Year 1 Pure Maths. Okay, now we are given over here that point A has the coordinates -2, -8, and this lies on my curve. This is my curve. Say, for example, the curve is y is equal to x cube, and I have a point A. We will say that this is -2, -8. It lies on the curve. Okay. And at this point A, the curve has the gradient G. What I need to show is that the gradient is equal to limit h tends to 0 and something. We know that the gradient at a point, the gradient of this curve at a point is given by using derivative of the function y is equal to x cube. So the gradient of this point, at this point g, is given by using the derivative of the function, that is limit h tends to 0, f of x plus h minus f of x, the whole divided by h. Now we know over here that my f of x is equal to x cube. So my f of x plus h will be equal to x plus h the whole cube. Okay, so I am going to just substitute over here. So it would be limit h tends to 0. In place of x plus h, I will write x plus h the whole cube minus x cube divided by h. Now I will expand my x plus h the whole cube. If I'm going to expand my x plus h the whole cube by binomial expansion, I know that this is equal to x cube plus 3x square h plus 3x h square plus h cube. And I'm going to put this minus x cube over h. I cut the x cube. So I'm left with the gradient of the curve at point A is is the derivative of the function which I'm using the definition of the first principle, definition of the derivative. So I am left with 3x square h plus 3x h square plus h cube, the whole divided by h. Okay. Now what will I do is I will divide it. I will divide the entire equation by h. So this becomes 3x square plus 3xh plus h square. Since I'm going to divide it by h, so h is getting cancelled. Okay. Now I'm going to cancel h as h tends to 0, but remember that h is not equal to 0. So g is equal to limit h tends to 0. Okay. And I have to prove what? Just take a minute and read the question. Then looking at the question, I know that I don't have to cancel h, so I don't need to substitute the value of h. So I have g is equal to limit h tends to 0. That means my gradient of the curve at point A is limit h tends to 0, 3x square plus 3xh plus h square. And I want to show that the gradient of the curve at point A, that is g, is equal to something that is given over here. You can read this. Now what do? I want to find the gradient at A, and my A is -2 comma -8. So I know we have x is equal to -2. So what will I do? I will substitute the value of x into this expression. So I have g is equal to limit h tends to 0, 3, instead of x, I'm going to put minus 2 square plus 3 xh. So 3 minus 2h plus h square. So I am going to have its limit h tends to 0. Minus 2 square is nothing but it is 4. So 4 into 3 is 12. 3 into minus 2 is minus 6h plus h square. And this is what exactly I had to prove. So I have proved that my g is equal to limit h tends to 0, 12 minus 6h plus h square. So this part is done. Now deduce the value of g. When I say deduce the value of g, that means I am supposed to find the B part. I am supposed to find g. Okay. So if I'm supposed to find g, I will take the limit as h tends to 0. So g is equal to limit h tends to 0, 12 minus 6h plus 8 square. So I say that as h is approaching 0, the term h vanishes. Okay, it disappears. So g will be equal to 12. Please remember, when I am vanishing h, I will remove this limit. So my final answer is the value of g is 12. Okay. When they say deduce the value of g, that means they're asking you to calculate the exact value of g. That's it. So this is exercise 8B, question number 3 at Excel Pure Maths Year 1.